Hi, cuties. You must be wondering, why do I need to limit the rate at which my API is being called? Well, Emmanuel is here to shed some light and valuable insights based on this topic. Hi, Emmanuel.
Hello, Aisha.
How are you doing?
I'm very fine today.
Could you please tell us a bit about yourself?
My name is Emmanuel. I'm a software developer with over 6 years working experience.
Oh.
Over the years, I've had the opportunity of working with a lot of fintech applications. And one thing with fintech is that people call our APIs very fast and at an alarming rate.
Okay.
So I'll say this topic is one that I have used firsthand.
Okay.
I've implemented basically.
Okay, so how long okay, you said 5 years. So are you a full stack? Like, do you do backend?
Well, I'm a full stack developer, but I am more backend centric.
Oh, okay. What do you write? What
C
language?
C#,
.NET, right?
Yes.
Oh, wow, that's cool. So talking about this topic, API rate limiting, what does it mean?
Well, API rate limiting is basically a technique that allows you to limit, control the rate at which your API is being called.
All right.
You can limit the number of calls to, let's say, a specified time period.
Okay.
So, for example, you have an API, you can say, for every 10 seconds, I want only 3 calls to hit this API.
Okay.
You might ask that, okay, why is that done? One major reason is, to prevent attacks. Because one common attack is DDoS attack, where your API is hit multiple times and it basically crashes your API in the long run.
Okay.
So API rate limiting is a very good way to prevent against that.
Okay, so when you say attack, are you talking about cyber attack now?
Yes, like bad actors. You have a public API. Your API is free. Okay, let me give an example. 2018, there was an incident with GitHub.
Okay.
GitHub basically went down for some time. Why? Because they had a public server that was exposed and attackers went and hit that server with so many requests, it basically crashed their system.
Okay.
So API rate limiting, would restrict that.
Okay.
So you can API rate limits with various criteria. For example, you can use an IP address.
Okay.
An IP address would not be able to call this API for more than 1,000 times in 1 minute. Cool. If he calls the API 1,000 times in 1 minute, meaning that person is very suspicious.
Trying to do something.
Exactly. So that's what I mean by attack.
Wow, that's good. What are the challenges developers face when they're trying to implement API rate limiting in their application?
Okay, so prior to .NET 7, API rate limiting had to be done using an external NuGet package.
Okay.
Or you have to write a custom implementation. But with the emergence of .NET 7, Microsoft, made API rate limiting an inbuilt feature. As a new developer wanting to, implement its API rate limiting, you might now be asking, okay, how do I do this? Which do I use? The thing with API rate limiting is that there are various algorithms to use.
Okay.
All right. There is the fixed window, the sliding window, token buckets, or the concurrency limits. So it all depends on your application use case and what the algorithm does. For example, one like fixed window would just allow for a fixed time period have this number of requests. One like token buckets is majorly for like bursts, for if your API can receive bursts of requests for a short period of time, then a cooldown. Token bucket is one way to go.
Oh, okay. So you talked about API call. So are you talking about just one API, one endpoint, or different endpoints? Okay,
so you can rate limit anything. You can rate limit your entire controller.
Okay.
You can have one rate limit policy that can then be used for every controller on your application or just various specific application. It is very customizable actually.
Okay. So, earlier you talked about, you said you've worked on fintech, you based on fintech application majorly. So, I'm sure you would really work with external APIs, other parties, third-party APIs. So, with third-party APIs, how can you work or undo the API rate limiting when you are calling them, especially when you're working on a single application? You sometimes, for you to achieve one particular thing, let's say one of our you need to work on let's say 3 endpoints, and let's say they have like rate limiting. How do you work on that? How do you undo that?
Okay. So I guess one major thing that you first think about is, okay, do I know this API is being rate limited?
Okay.
So let's work with the assumption that, okay, you're aware that this API is being rate limited. For you to call an API that is being rate limited, you know, earlier on this show, I think some episode back, you had a guest talk about resilience in your microservice that made use of poly.
Yeah.
Okay, poly for request throttling, for retries. So that is basically one way to go about it. You are calling an API that is rate limited. You need to, you know, find a way to configure poly into it, such that it is able to retry it in case of any failures. You can also, one thing with rate limited APIs is they always return 429. That's the error code.
Okay.
Too many requests. So you can create your strategy around that error code. When I see this error code, I can do this. One other thing would be, well, this one, let's say catching most responses you get from APIs. As you said, you're trying to test, you're calling APIs over and over again. You can catch some responses. So that way, instead of hitting the API, you get from your catch. Another way would be, let's say working with a tags.whenAll. Now, this has to do with when you are calling multiple APIs, you know, calling multiple APIs in such a way that one depends on another, depends on another. You can use a tags.whenAll such that everything goes or nothing works at all. So that way it is able to, you know, control your application and not really break things.
Okay, that's amazing. So what are some real world uses of API rate limiting?
Okay, I say the first one I said that earlier on is preventing against denial of service attack. I know I did not explain what denial of service is. Denial of service is basically when your API is hit with so many requests that it slows down its performance, or it starves every other service of resource because every resource is being dedicated to just one API, or in worst case, it might crash that API, crash that entire server. So working with a real life use of API rate limiting, preventing DDoS attacks. You can also use it for a paid application for like a SaaS product where you have different account tiers. You have a standard user, basic user, premium user. Standard user, you're entitled to 100 calls per month. Basic, 1,000 calls. Premium, 1 million. Working with rate limiting without thinking of too much implementation, you can easily rate limit these calls. You can rate limit these users based on their account type. That's another real life use case of rate limiting.
All right. Do you know, okay, talking about this rate limiting, concerned about these policies. Like this policies, it's the company that will just sit down and say, okay, these are the policies we want to carry out. Or after implementing our APIs, we'll look at it and say, this API cannot take too much calls. So let's limit it. Like how they like come up with all of those policies?
So is, as you said, it is based on your application's needs. For instance, let me give you an example of my experience working with fintech application. One thing people like to do is get the status of their transaction.
Definitely.
All right. So getting the status of your transaction, one person can call the API like 200 times.
True.
Exactly. So API rate limiting, you are able to then plan your policy. Okay. You're able to configure your policy in line with that request, that knowing that people will call this API too many times, more than they require. You can then put a limit on a particular reference number. Okay, this reference, if it calls more than 200 times, hold on for 1 minute, cool down before then trying again. So that's basically how
that makes sense. That makes sense. So, you know, talking about microservice application.
Okay.
If you mentioned microservice the other time. So if you want to work on a microservice architecture or application, and there are different services, multiple services, most times they work together. So how do you limit the rate at which these services work? Calls API for this service, you call another API for this service. Like, how do you limit the rate, or how do you undo the implementations?
Okay, good. How do you handle it? I'll answer the question in 2 ways.
Okay.
First of which is API rate limiting in microservices. Sometimes when you can configure, okay, this service should not call this service more than this amount of times. You do it such that, so that it will allow every resource, even sharing of resources, let me put it that way.
Okay.
So one service is not starving another service of resource because it's calling another one too many times.
Okay.
Another way to go about this is, one thing with microservices, let's give an example. We are working with a load balanced service, one that has several instances.
Okay.
The current .NET 7 implementation allows you to, it saves your keys, your API keys and everything in memory, your API rate limited keys in memory.
Okay.
Now, when you have multiple instances, you see you have 3 different memory. If your first load balance called the first service, second load balance called the second service, you have lost the counts there. So in such time, there's also the ability to implement third party, or rather to extend the rate limiting service and make use of an external DB source. Such that it is no longer in memory. You're using an external DB source that keeps track regardless of the instance of microservice being called. So that way everything works seamlessly, and it works seamlessly regardless of the instance, basically.
All right, thank you. So could you show us some live scenario, like some use cases through your code? Like, just show us how it works.
Okay, so sure. So earlier on, I spoke about the various algorithms that exist in API rate limiting.
Yeah.
So I'm just going to show us a little bit of them.
All right.
So first of all, to configure API rate limiting, it's this. It goes basically in your program.cs, in whichever is the entry point of your application. There is the add rate limiter inbuilt endpoint, inbuilt middleware on your application. All right. Adding the builder.services or add rate limiter, you also need to then use the rate limiter. Okay. So let's go ahead and just configure rate limiter.
All right.
As I said earlier on, that it is standard practice that the status code returned should always be 429. That way it lets someone know that, okay, there are too many requests. Okay, so first of all, you configure the status code. Then secondly, let us look at fixed window. So now working with the fixed window middleware, as I said, it's such that takes in within a configured time span, allow a certain number of requests. Now, one thing with this rate limit is you need to give them a policy name. For instance, I call this a fixed window. You can name it anything. I will take us to where we actually use this name. But moving on, we also have the add sliding window limiter. Sliding window is a lot more robust in the sense that it's basically a sliding window. Let me explain. It takes a block of time and divides it into segments. All right. And for every a permitted number of requests, we can have 15 seconds divided into 3 segments. We have 5 seconds, 5 seconds, 5 seconds. But we only permit 15 requests in that time span of 15 seconds. The way sliding window works, breaking down into segments, depending on the number of calls in the first segments, once the window slides, it takes all those requests and adds it to your total number. So it's basically a very dynamic
once it's up to
approach.
Once it's up to once it's up to 15, it stops.
It stops. It prevents any more calls till the next window.
So the next window will now be when?
5 seconds later, because 15 seconds divided into 3 segments.
Okay.
Next is the token bucket. As I explained, token bucket is for like when you know your API is going to receive a burst of requests. So for instance, here we configured a token limit of 100. There are 100 tokens in a particular bucket. And once you can call the APIs anyhow, it is not time based, but once all the tokens in the bucket finished, that's the end. But then we have a replenishment window. Now this replenishment period is how many seconds does it take before you replenish
the 100?
Exactly. But now you don't replenish the 100. You can then configure it to replenish a certain number of tokens per period. So it's just like allowing your application to cool down You just receive 100 requests, cool down, take 10 back. 10 seconds again, take another 10.
Okay.
10 seconds again, take another 10.
Okay.
Then there is also the concurrency limiter. Now, the concurrency limiter is basically, as the name implied, for concurrency. It can allow this number of requests at the same time. That is, it can only allow 5 requests at the same time.
Okay.
Anything, once it sees there are 6, the 6th one, it blocks that. This one is basically not time bound. It's just more of, concurrency.
Okay.
And how do you basically use this? As you see here, we defined every policy here with a name. Now, going to your controller, you see we have an attribute. It's called enable rate limiting. Like I said, you can rate limit a particular endpoint, or you can rate limit the entire controller. So it just depends on your use case. And the enable rate limiting attribute takes in a policy name. This is where the policy name comes in place.
Okay.
So this here is fixed window. Fixed window, as I said, we configured it that it allows 3 requests for every 10 seconds. So let me just quickly run the application.
Okay.
So the application is running now. Let us use Swagger to, call this endpoint.
Swagger, or?
Let's use Postman rather to call this endpoint. So calling the endpoints, call it the first time, 200, second time, 200, third time, 200, fourth time, 429, many requests. That's it. So using this, you are able to configure, okay, my API should not exceed this limit. After a couple of seconds cooldown, you call it again, successful, call it again, successful, call it again, failed. All right. So that way, that's basically how the fixed window works. But what if you want to now do for more dynamic configuration?
Okay.
For an example of, let's say, someone's IP address, you want to configure it based on an IP address. You can then create policies having access to the HTTP context, because they are using rate limit partition. You're able to get access to the user's HTTP context. This means you have access to the token, you have access to the header in the request, you have access to the user's identity himself. So that way you can even, specify someone's email, someone's account type. So in this example here, I'm rate limiting based on your IP address.
Okay.
And again, you give it a policy name. So this way you're able to, configure it such that this IP address should not receive more than 10 calls in 10 seconds. That's basically it. They also, the fact that you have access to the user context gives for more elaborate configuration. Imagine in this case, you have access to the user, you can know what role he is in. So you can say for a premium user, this is the rate limiting configured for you. Standard user, this is what's configured for you. That's basically it. It's an amazing concept.
It's nice. So for this IP limiter, did you for this event now, so the IP address, is this coming from .NET, or you're using an external?
No, is the IP address that is being used to call the API.
Okay.
Because your HTTP context carries your IP address. So when you call an API, it carries your IP address. They're able to know that
from the header.
Yes, yes, from the request itself.
All right. Thank you for this. So do you have any other things that you need to advise our audience based on this topic? One
thing is that I would advise, if you're building public APIs, that is accessible to everyone. This can actually save you a lot. This can save you a lot. Okay. There are times when your application will crash, basically. So this will save you a lot if you're building public APIs.
Yeah. Because you can't really like tell them this is what to do and this is what not to do. But if they have to sign in, you can easily.
Exactly.
Yeah, I get that. Thank you so much. Okay, so the code you just showed us, can you please share us the repo, the GitHub repo, so that our audience can check it out and see how it works?
Sure. I'll do that.
All right, thank you. Also, if our audience have questions to ask you based on this topic, or probably fintech, right? Can they reach out to you?
Yes, on my LinkedIn.
Okay.
Emmanuel Oriahi.
Okay.
Send me a message. I'll do to respond.
Thank you for coming. I really appreciate, and everything you explained is so insightful. We hope to have you here again. I hope you'll come.
Let's see how that goes. I enjoyed my time here also. Thank you so much.
All right. Okay, I believe you've learned one or two from Emmanuel. If you have any question, you can drop it on the channel, or you can also reach out to him on LinkedIn. Don't ask so much questions. I don't know, So, all right. Follow us on our socials. Subscribe to our YouTube channel if you have not. Share with your friends. Like. And, well, I remain your girl, Chazi. Stay tech savvy. Bye.